Before we dive into the episode, I've got some exciting news. I've just released my second course on Dometrain. The first course was on Docker, which was released last year, and this next one is on Kubernetes. It's a 6-hour course which is ram-packed with demos pretty much all the way through. The demos are super easy to follow along with all the scripts and YAML files provided. The course starts off with the basics, how to interact with Kubernetes, what are nodes, pods, deployments, services, and so on. Then later on in the course, we move on to more advanced topics, such as Helm, service meshes, operators, and more. And as a listener of the podcast, you get 20% off if you use the discount code PODDAN, which is all one word, all uppercase. And you can find it on dometrain.com, together with tons of other top quality courses. Now let's get on with the show. Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 66. And today I'm joined by James Eastham to chat about AWS and serverless development. So welcome to the show, James.
Thank you for having me on, Dan. Long-time listener, actually. So this is kind of cool to be here. Although we kind of realised before we started that I'm not even in the Discord channel, which kind of puts my long-term listener status to shame, really. So sorry for that.
I know. I was deeply offended. I very nearly cancelled the recording. So, well, trying to find you to invite you to the room, and I thought it was me not knowing how to use Discord. And it's like, where's James? And it's like, oh, he's not in it. Yes. So never mind. Never mind. So before we dig into AWS and serverless, could you introduce yourself to listeners and just tell us a bit about what you do?
I absolutely can, yeah. So I'm James Eastham. My official title at AWS is a senior cloud architect. What that means is that I'm in the professional services part of AWS. So I work much like any consultant would. I engage with customers, helping them build things on AWS. The kind of customers we deal with at AWS are obviously the bigger size, scale type customers. So it's really interesting, a lot of really high scale stuff, a lot of really interesting stuff. Before AWS, my background is in .NET development, hence me being a listener of this podcast, of course. I'm kind of an accidental .NET developer in that I left college being just before university here in the UK for anyone who's not in the UK. And I didn't really know what to do with myself, so I ended up doing frontline support for an IT company. Their system was built on .NET and SQL Server, and it was kind of like, well, I could support customers better if I learned how to do this coding stuff. And I think it's becoming more and more like a typical route into tech, that as opposed to like the university computer science degree, just like accidentally ending up being a developer. And yeah, so within AWS, as well as the consulting stuff, with my .NET background, I do a lot of work around serverless and .NET. So that's working with things like Lambda, not working on the .NET runtime, but helping publicize the .NET runtime, helping people use .NET and Lambda and serverless in the best possible way. So that's the other half. I like to say by day I'm a consultant, by night I'm a serverless .NET developer advocate, for lack of a better way of putting it.
Do you sleep in that?
Yeah, that's I do actually. Yeah, I find I'm really brutal with my time management. So I find I'm trying to make room for all these things somehow.
Or do you do all? It's not time boxing. What's it called? Time blocking. That was it.
Yeah, there's a whole process behind it. So end of a week, I'll block out my next week. At the end of a day, kind of shift stuff around if I need to. That includes exercise, running. I run ultra marathons, so.
Oh, nice.
There's all sorts in there. It gets a bit chaotic. So my calendar looks like absolute carnage. I open Outlook and I'm like, whoa, I've got a lot on today.
Yeah, I'm very similar because I put everything in my Google Calendar, but I use a tool called Cron, which kind of it uses Google Calendar as the back end, and it's so powerful. It's got so many keyboard shortcuts and everything, and you can resize and multi-select and do all sorts of stuff, and that is brilliant for time blocking.
Okay.
So I do very similar. I put the gym in there, I put time with the kids in there, just so everything's just blocked out.
What's that called? Cron?
Yes.
Cron calendar. Nice. Okay, there we are. Cool.
That could be my dev tip. I've done it early.
Yeah, nice.
So I guess where to start then? I guess it's worth mentioning that my background is Azure and I've hardly any experience in AWS. I think there's lots of one-to-one mappings though, like Azure Functions versus AWS Lambda.
Yeah, absolutely there is. Yeah, and I think that's the same for all the cloud providers. I think many of them are getting the same building blocks, skinned in a slightly different way with a slightly different set of features, but yeah, you can do the similar things. So yeah, Azure Functions, Google, it's not Google Cloud Run. Is it just Google Cloud Functions? I can't remember. Google have a similar serverless function type offering as well.
I'm not sure, to be honest. I've kind of, I knew about AWS Lambda, but I've not used it. But most of my stuff is in Azure. And I don't really know what the different Google, apart from Kubernetes, what the different Google services are.
Yeah, I don't know a lot about Google. I know quite a bit about Azure. I have done some work on Azure in the past. So conceptually, I've used things like App Service, Azure Functions, Container Apps, I think is the other one. But yeah, AWS is where I spend most of my life now.
Nice. Yeah, I thought I might be calling out Azure parallels, I guess, because I just don't know what the AWS ones are. But...
And I'll try and do the same. I'll try and do the same while we're chatting. If I know what a parallel service is, then I'll try and map that somehow.
Nice. So I think most of the listeners probably do already know what the term serverless means. But just in case, what's like the current definition of it? I think the phrase "somebody else's server" has already been pinched by the word cloud, I think.
Yeah, I mean, I think it's becoming more and more diluted. I think the word serverless, everything is becoming serverless now. The way I like to think about it is that serverless is like a spectrum, if you will, where at one far end, at the far right of the spectrum, you've got as serverless as possible, which is where you have little to no operational overhead. So that's something like Lambda, where you write your code, you push your code, and AWS handles everything else. At the other end of the spectrum is, running a server under your desk. Like, that's unserverless because you've got all of the operational responsibility. And then you've got all these different things that kind of sit somewhere along that spectrum. And I think you can get people get a bit dogmatic about, it's not serverless if it isn't scaled to zero, or if it isn't paid per millisecond or whatever. When I think that kind of is not the right way of looking at it, at least in my opinion. It's like I say, it's a spectrum, whereas at one end you have little to no operational responsibility and you might choose to step out. So when I speak to people, I talk about normally like thinking serverless, which is starting as far right as possible, starting as a default with as little operational responsibility as possible, and then step out from that if you need to. So let's say you've got a data processing workload, a machine learning workload where you need a GPU. Well, with Lambda, you can't add GPU. You control the CPU and the memory, and that's it. So at that point, you would need to step out to maybe Kubernetes and running, actual raw EC2 instances or the VMs and virtual machines on Azure to give you that GPU then. But for some other places in your entire system, you might use Lambda because you don't need that GPU compute. So you become more serverless. You have less operational responsibility.
How does it work with, I know you mentioned like GPU and things, but if you wanted, like for an enterprise application and you needed your function to be part of your private network, presumably then it can't be serverless.
Yep. So this is one of the actual interesting, so I've spoken at quite a few .NET user groups now, so I have done a little bit of trying to understand how Azure Functions work to map it to Lambda. And I think networking is one of the big fundamental differences to how Lambda and Azure Functions differ. So with Lambda, when you connect to a network, when you deploy your function, you simply specify a subnet that you want to attach your function to. And under the hood, Lambda just creates a network interface between the Lambda network where the function's actually executing and your own network. So Lambda still works in exactly the same way. You still have the same scaling. You still have the exact same operation responsibility. It's just that any egress from your function will route through your network as opposed to routing straight out from the Lambda network straight out to the public internet. So there's no additional cost to doing that. There's no additional overhead. You simply say, I want this function to attach to this network, and it does it. The first time you deploy the function, it takes quite a long time because it creates the network interface, it creates all the attachments and all that, but there's no more operational overhead.
When you say the first time it creates the function, does that include if you've got like a cold start as well?
So... No, not at all. So historically, maybe 4 or 5 years ago, if you had a function attached to a network, you did get impacted on cold start. Now it's almost negligible. I've never seen a noticeable difference. Whether you're attached to a VPC or you're not attached to a VPC, your cold start is going to be roughly the same.
No, that's really nice. Because it's been a while, even on Azure, since I've done like Azure Functions, because I do a lot in Kubernetes nowadays.
Yeah.
And when I did look into it, it was exactly that. It's kind of, they have an app service plan and you can choose for your Azure Functions whether it's consumption or whether it's based on like a non-consumption app service plan where you've got specific VMs behind it. And you couldn't do at the time, you couldn't do the consumption plan and have it attached to a VNet.
Right, okay. Interesting.
So it may have changed. So I don't want to say that's not how it is now, but that was kind of like an issue for me because a lot of my clients kind of, we want it private. So you ended up still using Azure Functions, but not being serverless and having like dedicated managed VMs behind it on the app service plan.
Mm-hmm.
And then if you're doing that, I don't know.
I completely agree. You might as well use a VM, like an app service, and yeah, I completely agree. And that's again where Lambda differs. I think in that the behavior of Lambda in terms of how it scales, how it runs, how it operates is exactly the same, whether you're attached to a VPC, whether you're not, what memory configuration you've got. You can even use things like there's a feature of Lambda called provision concurrency, which allows you to keep an environment available at all times. I think this another, I guess if we kind of take it back a step just for a second in terms of how Lambda actually works, because I think there are some subtle differences with how Lambda works versus Azure Functions. Again, this might be my lack of knowledge, but when a request comes into Lambda, it hits what's called the worker service, and that's the service that's going to decide where to actually execute your code. And it'll look around and it'll say, okay, do I have an existing environment available for this version of Dan's code? And if the answer to that question is no, what that service is going to do is it's going to create a macro VM. It's going to spin up like a completely isolated container. It's going to bootstrap the runtime. It's going to download your function code, whether that be a zip file or a container image. And then it's going to run the init phase, which is your constructors. That's going to initialize your .NET class. And then it's ready to receive the function. And then the actual payload, the actual request will be passed to the function. And that's what's known as a cold start. The reason I explain all of that is that these environments can only ever process one request at any one time. So if you got 3 requests into Lambda at the exact same millisecond, you're likely to get 3 separate environments, 3 separate cold starts in theory. These environments then hang around for a little while to, they stay warm. So then if another request comes in, the work service will say, do I have an existing environment for Dan's code that isn't already processing a request? Yes, I do. Send that there. That's a warm start. And you can have up to 1,000 of these environments by default in a given account. So you can scale up to 1,000 and then it will eventually scale itself back down. And this gets really interesting when you start attaching things to networks, because typically if you're attaching something to a network, you're attaching like a relational database or querying a relational database in the typical .NET application SQL server. You get 1,000 of these environments spin up, you get 1,000 concurrent connections to your database, and your database goes, I can't deal with all this load. And that's what kind of gives the Lambda this ability to scale up, scale down, attached to a VPC, not attached to a VPC, because each environment is spun up on its own. It does its work, shuts down again afterwards.
How does that work then? Because when I think of serverless, I think about it as being like almost infinite scale, and you can, if it can only have 1,000 requests at the same time, how does it go beyond that if you've got something like really like with lots and lots of traffic coming in?
So that's a soft limit. So that's just the default, and that's soft. So you can raise a ticket with support, and they can up that. And I know of customers who are well beyond that. And I mean, if you think about it, you can have 1,000 of these environments at once, and each environment can only be processing one request at any one time. And to keep the maths simple, if your requests take a second to process, you can then support 1,000 requests per second. I think I've got that maths right. If you can reduce your time to process a request from a second to 500 milliseconds, then you've doubled your TPS. So with .NET as being as performant as it is, as you and me both know, like it is a really fast language. It's not unusual to see like single-digit millisecond response times, double-digit millisecond response times. So although you can only have 1,000 of these environments, actually, if your actual application code is fast, it's performant, that will scale well, because if your request returns in 10 milliseconds, you can process 1,000 requests every 10 milliseconds.
But that's not taking advantage of like async await, so you can have multiple. It still just feels like a small default. But then even if it's a soft limit, is that creating, if you get 1,000, say you increase to 10,000, have you got 10,000 containers running to support that 10,000 requests? Under
the hood, yes, you would have, if you had 10,000 requests coming through at the same time, there will be 10,000 of these execution environments running at once. But as Dan, deploying the code, you don't need to care about that. That's AWS's problem. That's our problem. How we make sure there's enough resource available in the fleet to handle that scale up to 10,000, that's not for you to worry about.
I guess it's a nice problem to have when you get to that scale, having that many.
Yeah, I suppose, yeah, if you're in a situation where you've got 10,000 requests a second, then yeah.
So from I'm just thinking about the costing perspective of serverless. I know a lot in the past when I've looked at serverless, a lot of the hype has been around if you just need to do like bus loads and like lots of traffic, and it's just a lot more cost effective than having big VMs always open running 24/7.
Yeah, so Lambda is charged per millisecond that the code is actually executing. And if you're using one of the managed runtimes, that doesn't include your cold start. So if you had a 700 millisecond cold start and then your actual request took 7 milliseconds to process or 10 milliseconds to process, you'd be charged for 10 milliseconds. And when your code's idle, even though there's an execution environment sat there warm, waiting for your request to come in, you are not charged for that environment. You're only charged when your code is actually executing. So that's where, as you described, that you've got a really bursty workload. You could burst up and you'll get all these execution environments get created and they will stay around for a little while. So if that load stays, spikes up and then stays consistent for a period of time, you keep them environments, you'll keep warm starts, but you're still only paying for the millisecond that your code takes to execute.
Yeah, that makes sense. Yeah, I think a lot of my stuff I've already got like an infrastructure. Like we've spoken offline before about comparing things like Kubernetes and serverless and that kind of thing. And I think one comment you made was for quite a lot of stuff, you kind of want the best of both worlds and like almost a mix of both. Where and I totally agree. It's kind of like the reasoning behind the private networking is kind of part of the reason why we haven't used Azure Functions for that kind of requirement, and we are putting everything in Kubernetes. But yeah, it does feel that it'd be nice to have, just be able to jump between both. And it's good to actually hear that about what you're saying about AWS, that private networking, it just works TM.
Yeah. Although it can give you some really interesting, I've done it in the past where I've spent forever trying to fix a bug with Lambda. I'm like, why is this code not working? It keeps timing out. And then somewhere like 4 layers of abstraction down my .NET code, I was making a HTTP request somewhere and I hadn't set up the network to have public egress. So the second you attach that Lambda function to the network, there's no route to the internet. And I'm just like, why is it timing out? It's really annoying. And then eventually I was like, of course I'm making that HTTP call to arbitrary API. So, and there's a couple of little caveats in that when you deploy your function, that will use up a IP address in the CIDR range of the subnet that you attach it to. So you can, and that's per function, not per execution environment. So you've got 10 Lambda functions, you've got 10 IP addresses being used. If you tried to deploy an 11th and there's no more IPs in that CIDR range, then it would fail to deploy because there's no IP address to connect to. So there are a few little caveats, but yeah, mostly it just works.
Yeah, well, I guess if you make sure that you've got a big enough range when you're setting it up, then
and that would be no different. I mean, I'm not completely au fait with the internal way that networking works in Kubernetes, but if you had X number of services roughly mapped to X number of Lambda functions, that would use the same number of IP ranges, right? So it's not like it's an unusual problem for Lambda. It's just something that you need to think about.
No, definitely. We've had the same thing. So we've had to really allocate in the subnets a wide range because each pod has an IP address. So it's exactly the same kind of thing. I'm kind of thinking when, just with the Azure Function stuff, just thinking about all the marketing stuff I looked at, and it was kind of very much, you can just throw your code in the cloud and it's super easy and everything. But then kind of in reality, for your code, you want its source control, which means you kind of, I'm thinking from .NET, it might be different with other stuff, but which means you kind of need a project. When you've got a project, you kind of probably want to use dependency injection just because that's the .NET way of doing things. So you have a startup or program.cs. So the next thing you know, you've actually got a whole project anyway. So it's not just a function. Is that the kind of same kind of thing in AWS, or is it literally just a function that's in a file that you can put in source control?
No, so Lambda, you would still use a project file, you'd have a solution. There's a library we've developed called the Lambda Annotations Framework, which I think we can put a link to that in the show notes. And it brings the same programming model that you're used to, that we're all used to as .NET developers, like annotation-based programming that you would do that with an ASP.NET controller. Where you might annotate the root, you annotate this method is going to be a Lambda function. You can have your startup.cs file. You can use dependency injection. It brings that same programming model, and then when you come to deploy it, all you specify, there's a really specific string you give to Lambda, and the format of the string is the assembly name, the namespace in the class, and then the method name that you want to invoke. And then when Lambda actually invokes your function, it'll parse that string and be like, I want a DLL named Dan's function. In there should be a namespace of Dan.function. And then I'm going to instantiate that class. And then I want to invoke a method on that class called function handler, Dan's handler, whatever that might be. So yeah, you can still use all of that stuff. You can even run ASP.NET on Lambda. So we have a library, so you can add if you're using that minimal APIs, you can add a single line of code to your program.cs file, and you can literally just drop that ASP.NET app into Lambda. And then this come back to what you said before about serverless and containers. This starts to open up some really interesting use cases, because then you can run that exact same ASP.NET web application on Lambda, and in a container, like the library we've built is context aware. So it knows if it's running in Lambda and it executes slightly differently if it's running in a container or locally on your machine, like the typical start it up, debug it, you can do all of that. So you do have some really interesting things to keep the developer experience as familiar as possible as to what we're all used to as .NET developers.
Oh, that's interesting. So I'm thinking, again, I'm going to the parallel of Azure Functions where you've got the Azure Function runtime and you can run that locally. But it sounds like you're just saying just run it as a normal ASP.NET.
So I've flip-flopped quite a lot on this over the years. I used to be quite militant about if you're building an API with Lambda, you should have one Lambda function mapping to one route on your API. So you've got an API with 5 endpoints, you'd have 5 separate Lambda functions. What that means is that you're going to see more cold starts, if that makes sense, because each one of them different endpoints, if you had someone go bang, 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 hit all 5 endpoints, you're going to get 5 cold starts. When you start getting into the pattern of packaging ASP.NET up and running that on Lambda, your initial cold start is going to be slower because you've got to start up ASP.NET, of course. You've got to set up dependencies, you've got to do all that stuff. But if you think of that same scenario where you go bang, 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 hit the 5 endpoints one after the other, you're only going to get one cold start. You'll get the cold start on the first one, and then the next 4 are all routing to that same function, that same environment that's already warm. It's intuitively, it doesn't seem like it should be better because your initial cold start, like if you were to go and test it, Dan, you'd invoke the function manually and you'd be like, oh, that's really slow. Like that cold start's really bad. But when you put some actual load through it, because you've got all your requests routing to that same function, actually you will see a much lower number of cold starts overall. And it's the first thing I always say to people when they're working with Lambda and cold starts is don't just deploy your code, hit it once and be like, cold starts, darn you, cold starts. Like actually run some load through it. Like, okay, my application's going to take roughly 100 requests a second. Okay, do that for a minute and then go and look at the stats and then be like, okay, my 99.9 percentile is still good enough. And then you've got that last little bit where you're going to get a few cold starts and that might be okay for your workload and it might not. And there are workloads, like there's a system I worked on just before I started joining AWS where it was an incredibly spiky workload. We had no way to predict the traffic, but when we did get traffic, we needed single-digit, double-digit millisecond response time. That's a really tricky thing to do in Lambda. So what we ended up doing there is running part of it on a container, run like a front end on a container, ASP.NET on a container, and the ASP.NET app just did some validation and handed things off to a queue. And then you had Lambda reading off the queue. So you still had Lambda, you still had the scale up and down, you just had this really thin API layer on top of it. So there are certainly workloads where you might not use Lambda, you might use containers.
Yeah, that makes sense. I guess also like I'm thinking about a website that's it's not got traffic running all the time, so it's not a busy website. Then you're probably always, I assume, going to get that cold start the first time a customer hits it. So yeah, it's interesting what you're saying about like more event-driven kind of architectures to work around that.
Yeah, absolutely.
Thinking about Azure Functions, I know you've got like the concept of triggers, where we've already spoken about API endpoints, but like you can add triggers which are just attributes which set up, like if you wanted to listen to a service bus or something, a message broker, or various different things happening within Azure in this case, but I assume there's equivalent in AWS.
Yeah, absolutely. Yeah. Like most of the AWS services that you would, if you were building things in a serverless way, at least there's a serverless version of almost anything you could want, and a fully serverless version if we're being like dogmatic about it. There's event buses, there's topics, there's queues, there's streams. You can use Kafka, so you can source Lambda with Kafka. You can source it. There's a whole range of different things, and yeah, you just configure the source, and Lambda will do the rest. And there's even packages on NuGet. So it'd be like amazon.lambda.sqs events. And that will give you a strongly typed representation of the JSON. Everything that comes into Lambda is just a JSON payload. So if you invoke Lambda from an API, from API Gateway, the JSON that Lambda receives is just a complete JSON representation of your HTTP request. So you can just add a NuGet package and then you get a strongly typed implementation of the event payload. And the Lambda runtime, the .NET Lambda runtime will deserialize that on your behalf. So your actual method signature that you're going to invoke will be strongly typed. And if you're using this Lambda annotations framework that I talk about, you can take that one step further. So you could actually have a custom class as the method signature. And Lambda annotations will take the API request in, deserialize the body into the type, and then pass the type to your method. So it kind of takes away some of this abstraction. But yeah, there's a whole bunch. I think there's about 40, don't quote me on that, different event sources for Lambda.
Oh, nice. It is fascinating hearing all like the different parallels compared, like the different cloud platforms. It feels very, very similar. I guess another, so I'm putting everything into the context of Azure because that's what I know, but another Azure thing with functions is Azure Durable Functions, which manages state. Does Lambda have a kind of concept of dealing with state?
No, so Lambda is completely stateless. These execution environments are temporary. So they will, even if you've got a consistent load, eventually the Lambda service is going to start reaping these environments. It only lets them live for a certain period of time, and that's an undetermined period of time. Like that they will just disappear at some point. So it's completely stateless. If you were managing state, you'd probably use something like step functions, which is a workflow service. Is the easiest way to think about step functions. So it's a state machine with a set of steps, and you know, let's say you wanted to have you wanted to invoke 4 Lambda functions, one after the other. You would use step functions to orchestrate and manage the state of that. So no, Lambda is completely stateless. You can't even guarantee, you know, if you sent 2 requests into Lambda, there's no way to guarantee they'll even hit the same underlying machine. So yeah, it's completely stateless.
But you can almost like do that yourself, like you mentioned about messaging and stuff, like create a saga yourself, I guess, by just triggering messages.
Yeah, exactly. Yeah, you could, you know, your API endpoint could drop a message onto a queue, and then off the back of that queue, you trigger a workflow, and that does all your saga type stuff. Yeah.
Nice. And I guess another question, which is kind of like a topic that I'm quite fond of, is observability. I don't know, we've got like all like buzzwords like OTelemetry at the moment and all that kind of thing.
Yeah.
If you want to just see like metrics or logging or any of this kind of stuff from Lambda, how does that work?
So anything, let's go through the 3 pillars one by one, if you will. So logs, anything you write to standard out gets automatically forwarded onto Amazon CloudWatch, which is our logging, complete observability solution really, but insert there you've got logs. So you'll automatically get anything you write to standard out go into CloudWatch.
Is that just standard out, or is it iLog? Like, is there an iLogger?
So you could use iLogger, and let's say you're using like Serilog. As long as Serilog writes to console as your sync, then that would then come out into CloudWatch. But yeah, you could use iLogger if you're using dependency injection. Absolutely, that's logging. So then metrics, you get a whole bunch of metrics out the box. So Lambda will automatically give you data on things like execution time, how many concurrent execution environments you've got going on at any period of time. So you get a whole bunch of metrics out of the box. Obviously, you can add your own metrics in your application code. There's a feature of CloudWatch, which is the logging thing I was just talking about, called the embedded metric format, which if you write a log in a very specific format, CloudWatch will automatically read that and create metrics off the back of it. So you can write log messages to create metrics, basically. And then tracing, the AWS default is a service called X-Ray, which is our distributed tracing service. And you can just turn that on in your Lambda function. You can say Lambda activate tracing, and you will automatically start to see trace data. And then obviously anything inside your application code is up to you to trace yourself, because Lambda can't automatically trace your application code like individual method calls and stuff. So packaging all of that up, there are a set of libraries for Lambda called Lambda Power Tools. They started off as a Python project, and they've now been rolled out to almost all of the runtimes, you know, Python, Node, Java, .NET. I don't think there's a Go Power Tools yet, but I might be wrong. And that packages all this kind of stuff up. So if you use the logger from Power Tools, you automatically get structured logging, and it adds your function name, your trace ID, adds all that to your log. If you use the metrics implementation in Power Tools, it uses that embedded metric format I just described, but you don't need to worry about what the format is. You just say metric.addMetric, orders processed 1. And under the hood, that will create log messages and create metrics. And the same for tracing. You can use that annotations. You can add a attribute to your method and say trace this method, and Power Tools will automatically give you trace data on that specific method call. So there are libraries. And then of course, if you want to get into OpenTelemetry, you can do that. You can use OpenTelemetry from within a Lambda function, much like you can use OpenTelemetry in any .NET application. If you are using OpenTelemetry in Lambda, one of the things you need to be aware of is that as soon as your Lambda function stops processing a request, it finishes processing a request, it immediately freezes the execution environment. What that means is that if you're relying on like batch exporters in OpenTelemetry, if the environment is frozen before the exporter runs, you will never see the trace data in your tracing backend. So typically you've got to like manually flush your traces at the end of every request. So just before you return, you flush your traces, and then you get all your trace data in your backend.
That makes sense. You preempted my question about the OpenTelemetry side. So presumably, if you can use OpenTelemetry, you can push that to any like backend dashboards like Grafana or whatever.
So yeah, you can send it out to any backend, and yeah, you can send it anywhere.
Yeah, we had episode 41, Martin Thwaites from Honeycomb. Yeah, he was talking about OpenTelemetry. So that was quite a good episode. So I'll link to that in the show notes as well.
Yes, definitely.
So I'm going to go completely off topic now because on Twitter I've been seeing that you've been tweeting quite a bit about Rust, which I've never tried. I'm very curious.
Oh, it's amazing. It's so good. So I decided to start using Rust. So a lot of the stuff, I spend a lot of time thinking about sustainability. Like I'm vegan. Obviously, if you know a vegan, if you don't know vegan, they'll tell you straight away. So here I am telling everybody I'm a vegan. Although my Twitter handle is pretty obvious, actually. So I think a lot about things like sustainability and performance, and especially in the context of Lambda, where you've got the faster you can make a cold start, the less impactful they become, if that kind of makes sense. So I started exploring Rust for both reasons. You can do so much with such little memory allocation. That's the sustainability angle. And the performance is just so fast that then starts to address some of these challenges that you might see if you start using Lambda for applications. So I started exploring it. The learning curve is horrendous. Like, it is really different to anything I've programmed in before. But once you understand it and kind of it clicks and you realize the compiler is an absolute, like, it's just really, really picky and and you're like, why are you complaining about that? That's not a problem. Once you get past that, it's just brilliant. Like, null doesn't exist, which is a really cool thing. So like none, well, it kind of does, but it's strongly typed, if that makes sense. So when you return from a function, you can return a result, and a result will allow like have a success or an error. And then you have to handle that error. If you try and compile your code and you've not specifically handled that error, then Rust will get really, really picky about, you need to make sure you handle that. So it's just a really, really performant and really, really powerful. Like the type system is super flexible. So you can have enums, and enums can have methods, which sounds kind of weird, but it's actually, again, really...
That sounds horrible.
You might think that. So let me give you a specific scenario. So let's say you've got... Let me try and think of something off the top of my head now. You could have an error. So whereas in .NET, you might have like an order not found exception, a order exists exception, a whatever. In Rust, you might have an enum, which are all of your order exceptions, and each part of the enum would be order not created, order exists, etc. Okay. You've then got a method, and the signature of that method explicitly returns a order error. So that it returns the enum. When you then write the code to handle that function, you have to make sure that if you were writing an if statement or a match statement, it's like the pattern matching in Rust is one of the big things. You then have to make sure you handle every single type that enum could be, or else your program won't compile. Now, where that gets really interesting is that if you imagine go back to the .NET example, and Dan, if you go in and add a new type of exception, you had Dan's fancy exception. Unless you remember to go and add a specific catch block for that, your .NET code would compile, you'd push it out, and then you'd be like, oh no, we've not handled Dan's new fancy exception. Rust, your program simply wouldn't compile because you've not handled that branch of the enum, if you will. And it's just a super powerful language. Like I said, the learning curve is like steep, but once you kind of get it, and there's a book which is right over there that I won't get called Zero to Production Rust, which is what made it click for me. Like, you walk through building an entire application from setting up your local project structure right through to adding observability, adding resilient processing, caching, session state. Like, you go through this whole process of building a newsletter application. So yeah, like I can't wax lyrical about it enough. Like, it really is really, really, like, I feel like there's a bit of a hype train around Rust. Like, it seems like it's really hyped, and actually from being involved in it and getting quite deep into it over the last few months, I understand the hype because it is such a powerful language.
There was definitely a Martin Thwaites quote there. Was it not him that said wax lyrical? I think he said that on the podcast.
Maybe it's a northern thing.
Oh, maybe. I've never heard anyone say it, but you and Martin.
There we are. So yeah, I would honestly recommend checking it out if you're at all interested. Like I say, it's the learning curve is hard, but I mean, what I found really useful when I was learning it is that, and I can do this with anything new. Like I've started doing quite a bit of Java content as well, just because the languages are very similar. They have similar challenges on Lambda. They're very similar the way you build with them. And rather than trying to start from like hello world, like the most basic hello world, I always start from like the context of Lambda. So I will start with a Lambda function. Okay, how do I write a Lambda function in Java? How do I write a Lambda function in Rust? Because then you have some context that you understand. It feels slightly more advanced than just like, console write line hello world, but you're not going so far that you're like, what's Kubernetes? So yeah, I would recommend it highly.
A lot of the things you said then remind me of F# as well. Like with the nullability and the being like, if you had another enum or something that you get that protection.
Yeah, I'm not hugely into any of the functional languages, but from what I do understand, it seems like Rust kind of sits in the middle between .NET, Java, F#, Haskell, whatever. Rust kind of sits in the middle in that it's not really object-oriented, but it's also not really completely functional. It's kind of in the middle somewhere. At least there's maybe some Rust people listening to this now being like, what is James talking about? He's talking rubbish. But that's my read on it, at least from someone who's been doing Rust for like 4 months. So yeah, that's how I would sit it.
Well, at least if any Rust people are listening to that, then you get the feedback and you learn. I think
absolutely.
I always think that about any type of feedback is positive because you're learning something from it, whichever way it goes.
100%. I did a whole bunch of Rust content on my YouTube channel last year. And I started every video saying like, please, if you're watching this and you're a Rust developer and I do something horribly, horribly wrong, then let me know, because like I say, you want to learn.
Yeah, definitely. And speaking of like videos and content creation, we've actually, the listeners know that I've done a Docker Dometrain course, and we had Nick Chapsos on talking about that a few episodes ago. And you've actually beaten me to it with 2 out now.
I do have 2, yeah. So the first one I did, I think that released July, maybe August, on software architecture. So like a beginner's guide to software architecture. And then the one I released just before Christmas was on microservices, like a deep dive into microservices specifically. Now, both of these courses they're introductory courses, like I say. So there's not a lot of like code examples in them. It's more like conceptually understanding software architecture and why architecture is important. Understanding microservices and why microservices are important. When would you want to use microservices? When wouldn't you want to use microservices? How to do observability in microservices. But it's not, the course isn't really opinionated in a sense of, if you're building microservices with .NET, go and use this library, this library, this library, and this library. Now, next year, there may be more courses coming where I do get a bit more opinionated about some of this stuff. The architecture one particularly was really interesting because I think architecture, I think it's kind of got a few negative connotations around it, the word architecture, particularly from the world of like enterprise architecture, like traditional ivory tower enterprise architecture. And I think where the software world has tried to get more agile, more dynamic, I think architecture has maybe kind of become less important. Maybe, well, it's perceived as being less important because it slows things down, because enterprise architecture always say you can't do this, you can't do that, you've got to do this, you've got to do that. Whereas actually it's so important to understand. I don't know if you've heard of Gregor Hoppe. So he wrote Enterprise Integration Patterns. He's also wrote a book called The Software Architect's Elevator, which talks about like the value of an architect is to sit with the business leaders and then ride the elevator down to the engine room and sit with the engineers, and then ride the elevator back up to talk to them. You're kind of that conduit between one and the other. And I think I think it was really interesting going through that course and like refreshing my own mind on why architecture is so important.
A lot of these terms are becoming overloaded now. So you've got like architecture, DevOps, platform engineering, and all of these different things where it's kind of, is it a Venn diagram, the one that with the overlaps? There's lots of overlaps between the different responsibilities, as well as the responsibilities of normal developers that aren't, air quotes, software architects. Yeah,
and I think actually architecture, in my mind at least, should be something that becomes part of a development team. Like, you're working at a large organization building microservices, you shouldn't necessarily have enterprise architecture, like that architecture sitting across the entire system saying like, Dan, you must do this, Dan, you must do that. The way I see architecture potentially working well is that each individual team is responsible for its own architecture. And then you do have some kind of centralized architecture function that functions much like an enabling team in team topologies, if you're familiar with team topologies. So they're there to upskill the individual teams on how to do architecture. And maybe they do architecture reviews because the centralized architecture function has a bigger picture view of the entire architecture. Maybe they set guardrails like, Jeff Bezos' famous API mandate where all inter-team communication must be through APIs. Maybe that's a guardrail you put in place as architecture, but actually underneath that, it's completely up to the team to do exactly whatever they want. Do they want to use Rust? Fine. Do they want to use .NET? Fine. Do they want to use Lambda? Do they want to use containers? It's up to that individual team to decide. And then the architecture function enables people to make the decisions in the right way. So that's kind of how I see it working well. There's still an awful lot of enterprise architecture out there that's just like, you can't do that, you can do that. It's hard.
I do find it a tricky balance though with the team autonomy, because it's like if a company's got multiple different teams and you might have developers swapping between them, and one team go off and say, oh, the lead fancies using Rust, and they go off and use Rust, and then a year later they leave, and then everyone's got to stuck with Rust and everything. And also it's kind of like it's really difficult to have, like, say you've got more, I think about DevOps pipelines and shared stuff, which rather than every team having to reinvent the wheel with CI/CD or the different bits and bobs that are involved, creating new projects. If you've got like, for example, .NET templates to spin things up. Yep. But then you can take it too far and developers be unhappy because they've got no freedom to use their imagination. And I think it's just a fine line, isn't it, where that right balance is?
Absolutely, yeah. And I think, fundamentally, architecture should be driven by the business needs. That's one of the things I talk about in the course. Is like the first module is all about understanding the business context, understanding that side of things. And there may be a situation where, as the centralized architecture function, whatever that might be, you strongly suggest that all teams use .NET for reason X, Y, and Z. But as long as the development teams understand the reason why you're saying that, why you're saying you have to use .NET because of X, Y, and Z. One of the business goals is to be able to hire 1,000 new engineers in the next 12 months. Okay, well, picking Rust might not help you meet that goal because there simply aren't as many Rust engineers as there are .NET engineers. If there's a business goal for a certain part of the system, I'm absolutely making this up as I go along now, so this might be absolute nonsense, but if the business goal is to increase customer satisfaction and make the website more responsive, more, it does things faster, it feels faster, then that might wing its way down to that specific microservices team to experiment with Rust. Maybe, I don't know. But I don't know. I feel like if I was, it's been a long time since I've been like an actual, well, not a long time, 3 years. It's a long time in the tech world, isn't it? But I feel like if you know why you're being told, why you're being asked to use a certain programming language or build things in a certain way, that's fine. And I think if you have the ability as an individual team to run a POC, and this might be where you bring the centralized architecture function back in. So me and you, Dan, might decide, well, for our specific service, Rust is the right solution for reason X, Y, and Z. We run a POC. We say, here's the reasons why we're using Rust. We go back to some higher power. Here's what Rust is going to achieve. X, Y, this is going to be this much faster. We're going to be able to have this much throughput. We're going to be able to use this much, like 50, 60% less memory, CPU on our machines. And they might say, okay, tick, for you, you can use Rust, and that's fine. So I think that is the communication. And this is where this architect's elevator idea becomes really important, because then you've got somebody who's involved in the business side of things, but also deeply technical. Like they're actually down in the engine room, like they're working on production issues. Because in my mind, an architect should be involved in outages, because then you know where the limits of the system are, and then you know how you need to architect the system differently.
Yeah, it's like with putting developers in support so that they see, and then when they're developing, they're kind of thinking, okay, I'm going to have to be woken up at 2 a.m. and investigate this. What kind of observability can I put into this?
100%.
Because what's going to help future me when I have to investigate this?
Yeah, 100% agree.
So going back to the Dometrain course, out of interest, how did you find it? I know we spoke a bit beforehand, but...
The first one, it took me a lot longer than I thought. And actually, I think the bit that took me the scripting, the recording, that was all pretty time box. It's going to take me this long to record the video, this long to... The editing just took me so much longer than I thought it would. Like, so much longer. I've been doing YouTube content for quite a while now, so that the talking to a camera, all that side of it was fine. But yeah, the editing, that's what got me, I think. And, we were saying before, like, now that I've done the second one, I think you said the same with the one that you're doing now, like, the workflow is so much faster. Like, I've got into a good cadence now of, like... Because when I did the first one, I scripted the whole thing, recorded the whole thing, edited the whole thing. And I think it's actually from a conversation with you where correct me if I'm wrong, but you do like a module at a time. So you script a module, record a module, edit a module, script a module, record a module, edit a module. Is that right?
Yeah, so I've kind of like broken it down. So I start off with a mind map and break it all down, the whole thing down, then put it into Notion as a table. So I've got like the list of all the modules and the sections in the modules broken down, but that's as much detail as I go into it. But I've kind of like got the whole plan of, but without the detail, it's just what each section will be.
Yeah.
And then, I do one at a time. So I script it, so I script it in Notion, put like a bullet pointed list of like setup prerequisites. So for example, if I'm doing some code or if I need to show a website, for example, a checklist to open that website when I start recording, have Rider open with a certain project or file open, just so I've got a checklist of just before recording, this is what I need to set up. And then there's bits that script, there's bits I'll just, if I'm actually coding while doing it, where I don't need to script because I'm doing it so I'm just articulating what I'm doing. So I think one thing that made a big difference is that in conversations with Nick initially, we had a few chats about the editing process, and he was saying, don't worry about jump cuts, and that's one thing I was worried about. If I've got my webcam on, then that means I can't chop out mistakes or do anything. And he was saying it would much rather have more jump cuts, but it'd be clean and not pausing and uncomfortable while you work out your next bit. So I've kind of like just got into the flow of, as I'm recording, I know where I'm going to, if I'm stopping, having a think about the next bit. So I try to not move while I think about the next bit, like keep as still as I can. And then I'll carry on. And then also if I'm sharing my screen, I know not to move the mouse. I also know I don't move the mouse. I don't move the mouse or anything when I'm not talking. So then when I'm editing, it's really obvious from the waveform what I'm chopping. So I can quickly chop it down and make it really succinct and it flow quite nicely, and that works really well.
Sounds like you've got a much better process than me. I have the little scripting. This time I definitely did the like module at a time, and that really helped because last time, the first one, I kind of got like fatigued by just recording or just editing or just scripting. So chunking it down in that way, I really like the prerequisite idea. I'm going to take that for my YouTube. Like there was I think I recorded like half of a module for the microservices course. And then I went back to look at it, and I've got like a drawing tablet, so I can do like whiteboarding. And I was like, I'll just go back and watch some of these videos, and the whiteboard wasn't working properly. So I recorded all these videos, and I was talking, and then you could just see my desktop, like you couldn't actually see the whiteboard. And I was like, come on. Like, so a checklist of prerequisites, like make sure whiteboard is working, make sure mic is turned on, make sure website is open, code is open. Like, I really like that. It's a really good idea. That's certainly, I'm going to steal that down. Even for YouTube as well, the YouTube content, like having a checklist of before starting recording a video, because I've done that so many times. The biggest mistake I ever made, actually, I recorded a really long video once, and the raw video file was called, say, James.mp3, whatever, MP4. When I then exported from DaVinci Resolve, I exported the file with the same name as the raw file into the same folder. And for some reason, it popped up saying, do you want to overwrite? And I was like, yeah, whatever. And immediately, DaVinci Resolve was like, what? The file's gone. It just crashed out. And I was like, oh, what have I done? I've overwritten because it was overwritten. You couldn't retrieve it from the bin. Like, it was... Yeah, that was painful day.
Yeah, I think you tweeted out about that. That rings a bell.
I think I did. Yeah, it's really annoying. But you learn these lessons and you never do it again because you've learned the lesson to always check your mic. Now I've got a raw folder and an output folder in my editing folder on my laptop. So yeah, but it's a lot of fun. The courses. I don't know if you found the same, but I found it really helped to refresh my memory on some, like especially particularly the microservices one. Like, I watched a whole bunch of videos, I reread like Sam Newman's book, like reread a whole lot of concepts, and actually teaching something. So there's a quote from somebody, I want to say it's Einstein, but I don't think it is, but like the best way to show that you know something is to teach it. And I think teaching these kind of topics really helps solidify your own understanding and your own beliefs on how things should be done and how things should be built. So I really enjoyed that side of it, like just refreshing my own memory on how to do stuff.
Yeah, I found the same. It's not just refreshing my memory either. I found that when you're doing a whole course on something, that you've always got little gaps of knowledge where you think you've wanted to learn like this little bit at some point, but you've never had a reason to do it. But when you're doing a full course, even though might know 96% of it, there's these little bits where it forces you to read up and play around and have a go with those things. So it's almost like if you're doing, when you're doing like a certification and something that your work wouldn't have required you to look into, you've got to like look into like a more broad range of stuff.
Yeah.
It's the same with a course.
Yeah, I've had that actually. I said to you the other day, but I'm certainly going to be buying your Kubernetes course because I've been doing a whole bunch of Kubernetes at work recently. Like, it's the interesting thing about my job because I'm a consultant. I typically work on the thing that the customer wants to build that I'm working with. So, although I do a whole lot of serverless stuff, and that is absolutely my area of interest, where I think the vast majority of companies should at least start with as serverless as possible. Like I said at the start, like thinking serverless. But I have been doing a whole lot of Kubernetes recently, and that's really helped to broaden my knowledge in areas that. It's the nice thing about consulting. I don't know if you find the same with, the kind of work you do a bit more. You pick up things that you might not normally look at because you're forced to, because the customer you're working with says, well, we want to use Kubernetes. And you're like, right, well, okay, Kubernetes it is then.
Yeah, I do. It's kind of like lots of my contracts are kind of longer term anyway. So it's kind of,
okay.
So I'm kind of like wary about taking a contract which is about technology I'm not interested in, or I prefer to go into a contract as a specialist of X. But Kubernetes is definitely an interesting one because it's like you were talking about before about Rust being a learning curve, but then amazing. And I find the same with like Kubernetes. It's a bit of a learning curve, but actually once it clicks, it's just so good. And like, it's similar, like I don't want to compare Kubernetes with Git, but it's kind of from that point of view of a bit of a learning curve, and then it's amazing.
Yeah.
Like developers that haven't spent time actually understanding and learning about even fundamental things like rebasing. A lot of developers are scared off with rebasing and stuff. Where actually, if you go past that learning curve and understand how Git works and rebasing, it's just you can just use it without thinking about it.
Yeah.
It's so powerful, and I find the same with Kubernetes.
And I mean, you could even argue the same for serverless, right? Like some of the stuff that comes along with working with Lambda, like cold starts. Once you understand them, you understand how to work with them, ways to prevent them, ways to optimize your code to kind of get around it, then you're in this. I think, and I'm guilty of this, especially with Kubernetes, I'm guilty of this of anybody. I think it's really valuable to learn enough about the other side of the argument, if that makes sense. So I think it's certainly one of the things that I need to do. That's why I say I'll probably be buying your course when you release it, because I think I've got a level of understanding that comes from me just needing to know it. I think that Git rebase example is the perfect example. I think that's where I'm at with Kubernetes. I'm like just about enough to be slightly dangerous, probably too dangerous because I don't really understand the real fundamentals. It's why I've started with the courses I did on Dometrain with the fundamentals. Like, let's not go straight into how to build a multi-microservice saga in .NET, because actually let's understand what a saga is and why you need it, and that base level of understanding. So yeah, I think I do need to learn more about Kubernetes because everyone, and I absolutely like to clarify my standing on the topic. I absolutely believe that there are use cases for Kubernetes in the world. Like I don't think everything should be serverless or everything should be Kubernetes. I think it's picking the right tool for the job that you have. Like if you've got an internal HR application that's accessed 3 times a quarter and 900 millisecond cold start when it is accessed is okay because it's internal, it's HR, it's fine. I'd argue the overhead of running that on Kubernetes, the operational aspect of running that on Kubernetes is more than let's just run it on Lambda or let's just run it on App Runner, AWS App Runner, which is kind of a parallel to like Azure Web Apps. Why would you not do that instead? That's let's not just I don't know. Maybe it's an industry we're all guilty of. Like everyone has to be on a side. Like you're either .NET or Java, you're either Kubernetes or serverless, you're either X or Y. Whereas actually, it's the right tool for the job, isn't it? It's like whatever you're working on.
It's the typical answer. It depends.
Always.
Going back to the Kubernetes thing where you were saying about I think you said something about like jumping straight in the more complicated stuff, and it made me think about with my course a lot of Kubernetes content jump straight into Kubernetes architecture before it's explained some of the other stuff, and it's talking about like control planes, kube proxy, and all this kind of stuff, etcd. And I personally think that's the wrong order, especially for developers. So I kind of like I'm doing that later on in the course and explaining from a developer point of view things like pod services, ingresses, and how to use it, like using the kubectl command line tool, using K9s or Lens, like how you interact with it. But I'm putting off the things you kind of like implementation details that you're not going to use directly, and focusing initially on the things that you're actually going to use. Like, and later in the course, I'll do Helm and that kind of thing. But then I will have a section talking about the architecture. But I just think a lot of Kubernetes training content starts off with that architecture, and it just sounds so like it's like overly complicated because you've not got the context when you're hearing things you're not going to be using directly anyway.
Yeah.
Without the context of what you are going to be using.
Yeah. That's really interesting, actually, to bring it back down to Rust again. Like the couple of other Rust books I read before I read the zero to production that I was talking about. They started off with some of like but they got into some of like the really deep language features of Rust. And at a certain point, it does get to like I'm not a classically trained computer pro, because some of the stuff in Rust, I'm like, what does that even mean? Like, what did it for me with that zero to production book is that you are building an actual application, almost exactly what you said. You're starting from the things that you need to care about. Here's a framework to use to bootstrap a web application. Here's how to structure your project. Here's how to interact with a database. Here's the libraries you want to use. I think that sounds like a really nice way of doing your Kubernetes course, because like you said, the work I've done with Kubernetes has almost entirely been with ingress, services, deployments, Helm. I know that kubeproxy is a thing. I know that it exists somewhere. Kubelet, that's what runs on all the nodes, right? Kubelet.
Yes.
So I'm excited to see that course.
Cool. It's good that you've confirmed that it feels like I am doing it in the right order now by putting that off till later.
Yeah, it's something after reading this zero to production book, I'm tentatively thinking about either doing a course or a book myself on the similar thing for .NET and serverless, like walk through how to build an actual real application as opposed to here's conceptually how Lambda works.
Nice. So you've already done your dev tip, haven't you?
Yes, and I guess if we reaffirm it is OpenTelemetry for one, because the more I've got into OpenTelemetry, mostly driven by Martin harassing me on Twitter, actually. So thanks, Martin, if you're listening for all.
He does that.
He does do that. Yeah, he's an excellent nerd sniper. He actually taught me the term nerd snipe. He sent me a message on Twitter. He was like, how would you do OpenTelemetry in Lambda? It wasn't that, but something like that. I was like, I don't know, Martin. And then like 2 a.m. later, I'm like, here we go, Martin. This is how you do it. So yeah, I love OpenTelemetry because I like the flexibility it gives you in that. So the Rust application that I've been working on, I've got is configured to use OpenTelemetry. When I run it locally, it uses Jaeger. So I can run Jaeger locally on my machine alongside and everything's just local. And then when I deploy it, I don't change a single line of code. I just change some configuration. And instead the traces go to Honeycomb instead of Jaeger. And it's that standardized format that makes it really cool, really powerful.
Cool. So my dev tip is, I saw this article about something that's happened recently. It's called When Everything Becomes Too Much, the NPM Package Chaos of 2024. I don't know whether you heard about this, but
I did not.
So I'm going to quote the headline of the article here. An NPM user named Patrick JS launched a troll campaign with a package called Everything, which depends on all public NPM packages. So basically anyone that installed it basically completely filled up their hard drive and crashed the computer totally. And also there was, because NPM had a policy, I think they made a policy change in 2016. There was something called a left pad incident. I don't know the details of that.
Yeah, I think I remember that.
So basically, because of that change, it meant that no authors could unpublish their own packages. I don't know if it's still there, I haven't checked, but it's still very funny. I'll include a link to that in the show notes.
That's amazing. That feels like it'd be something so easy to accidentally install as well, like npm I everything bye laptop. That's great. Well, it's not great for people who've actually installed it, but it's great otherwise.
For the listeners, don't try this at home.
Yes, absolutely.
So have we, I think we're pretty much running out of time, but is there anything that we've not covered that you wanted to?
I don't think so. No, I mean the big thing I would reiterate, for anyone who's trying out .NET and Lambda, and we can obviously put some links in the show note, but running ASP.NET on Lambda is a perfectly good way to start. You might read some stuff on the internet talking about like Lambda liths and Lambda liths being a bad idea. They're not. So start there because that's a really easy way to get started because you're using ASP.NET that you're familiar with. You can deploy that into Lambda. You can use a single line of code in your startup file and it will just run there. And then the second part of that is if you are getting started with Lambda and you are trying Lambda, be aware that as a developer, you're going to see a cold start. Every time you deploy a new version of your code, you are guaranteed to get a cold start. Every time you change a configuration, you're guaranteed to get a cold start. So don't base your analysis off, is Lambda right for my workload, off one deployment of your code and one invoke. Like hit it with some load. You get 1 million free invokes every month. That's the free tier of Lambda, 1 million free invokes forever. So actually hit it with some load and then look at the metrics and then be like, okay, 99.99% of my requests are absolutely fine.
Would you tend to, as part of your CI/CD pipeline, once you've deployed it, then fire off a request just to warm it up?
You could do that. There was a whole thing that I think people still do it now, where you could set up there's a service called Event Bridge, which is like the event bus, maybe it's event bus, and you can set up scheduled jobs in there. So you can set up like a cron, and people would set up a cron job to invoke their Lambda function every 5 minutes to keep it warm. You could do that, and you could do what you say. You could send a request to prevent the cold start, but actually then if you receive 3 requests into that function at exactly the same time, you're still going to get 2 cold starts. So actually, it doesn't really give you an awful lot doing that. And again, it's important to be data-driven about your choice with Lambda, and it may absolutely be that Lambda's not the right fit for that workload. Okay, then look at running it on containers. Absolutely fine. But be intentional about putting some actual load through it, I guess is what I'm saying. It's one of like the kind of curious cases of Lambda as opposed to other compute options, is that the more load you give it, the better it performs, if that makes sense. Like if you give it consistent heavy load, it will perform better than really incremental spiky load that's all over the place and unpredictable. So yeah, just be data driven about it and actually look at it with your real application load. That'd be the final thing I would say, with not just .NET on Lambda for that matter, any language on Lambda.
Nice. I know you said you had a meeting at 5:30, which is 5 minutes, so I will give you time to go and grab a coffee, but where's the best place for listeners to reach out to you if they do want to get in touch?
Twitter or LinkedIn is where I'm typically most active. Yeah, I tend to do a bit more on LinkedIn nowadays, but yeah, I'm still pretty active on both social medias. And then on YouTube, annoyingly, my tag on YouTube is different. So on Twitter, I'm at Plant Power James, and YouTube, I'm at Serverless James. So yeah, any of them places, feel free to reach out. I'm always open to questions, and if you are listening and you're working with Lambda, reach out, and I'm always open to have a chat. If you want to have a meeting, a deep dive into your specific use case, then please reach out. We can chat about it. I'd love to speak to you.
Cool. I'll include all those social links in the show notes, and I'll also include both of your Dometrain courses in the show notes too as well.
Perfect. Nice. Thank you.
Cool. Well, a massive thank you for joining me on the show. It's been fun geeking out on AWS, which is another thing I need to add to my list of things to do. I just need more time, but yeah. AWS and Rust, it's just, this list is getting longer. But yeah, thank you for coming on.
No, thank you for having me. It's been awesome. And yeah, it's the ever-growing challenge of working in tech, isn't it? The never-ending to-do list of things to learn. But no, thanks for having me on, Dan. It's been a lot of fun.